Welcome everyone to the Spoken Nerd, the podcast about database technology. I'm your host Connor McDonald and I'm coming to you with a bandage on my left arm. I've just got my second COVID vaccination shot this morning and I must admit it knocks you about a bit, but I'd much rather be vaccinated than ill. On that note, please everyone stay safe, stay healthy. Even though you're listening to a podcast, one would imagine hopefully at some stage in the future, we'll be meeting up again in person for some face-to-face talk on tech. If you are listening to this podcast, I also know that the Tokyo Olympics is currently on, so thank you for taking the time to listen to the podcast as opposed to checking out the finest athletes in the world. In this episode, I'm going to take off my developer hat to some degree and take off my DBA hat to another degree and talk about testing, which is something that we probably often don't think about strictly as developers or DBAs, but hopefully at the end of this episode, I will have convinced you that you should be. I'm not going to talk about probably the most commonly spoken about topics when it comes to testing nowadays, and that is automation and DevOps and unit testing and having all those test suites, the kinds of things that we want to automate. There's a big focus on automation nowadays. The reason I'm not going to talk about that is there's heaps of content out there already about that, and I'll be honest, it's not my particular area of expertise. The area of testing I want to talk about today is what I call blue sky development, and I'll explain that in a second. This is perhaps where I do have some more expertise simply because I've been in the development and DBA world for nearly 30 years now, so I've seen my fair share of both successful and unsuccessful project implementations regarding the Oracle database. I've discovered that I think most of those failures generally come back to the concept of blue sky development. So without further ado, let me explain what I mean by blue sky development and blue sky developers. Psychologically, I think we are programmed to have a bias when we write code. That bias is that we want to be successful. We want to enjoy and reap the benefits of what we've written. As humans, we always enjoy being successful at any of the tasks that we undertake, whether they be job-related or otherwise. Therefore, as a developer, if I'm writing code, generally I value myself on writing working code. And that mechanism flows through the entire IT industry. You are valued not on the code you write, you are valued on working code. You are generally remunerated on working code. You get your bonuses, you get your pay rises, you get your promotions, etc., generally on the basis of working functional code, therefore happy customers. Unfortunately, however, that psychological condition, I think, blinkers us toward the focus on bugs and bug testing. Don't get me wrong. The vast majority of developers I encounter are fervent when it comes to writing unit tests and they're active in terms of system testing. However, underpinning all of that is ideally they don't want to find bugs. These unit tests are written because what we really want to achieve is a validation of that the code we wrote is actually working under normal conditions. This is what I call the blue sky approach. The code we write in our applications is very much focused toward the normal operation of your system when all the conditions are just right. Extending that metaphor, what we really want to be focusing on is not just the blue sky. We want our applications also to work when the conditions get a little bit stormy. A term I've often heard in relation to this is the phrase testing to destruction. And that is trying to make your application, trying to make your product, your code, fail under a specific set of circumstances that you expect to encounter in production. I want to stress, both elements of that last sentence are crucial. You want to make your application fail, and you want to make it fail under expected circumstances that you might encounter in production. This is a real art. This is not something that's easy to do. The easiest way to test a destruction is also not particularly useful. Easy way is heading into the realms of what I call insanity testing. I once was involved in a system where we were taking sales from customers, and on our first cut of the code that we pushed through to our test environment, one of our testers came back to us and said, when I type in a quantity of 1 trillion for a particular product, then the application fails and crashes. That is indeed a valid test case to examine and is indeed a bug in the application. But the likelihood of any customer in a true production environment typing in 1 trillion as a quantity for the number of products they wish to order is extremely low, and even if the application did crash during this, the impact is negligible. This is a danger that both developers and testers can fall into in terms of coming up with test cases that are so far beyond what you would genuinely expect to encounter in production that the test doesn't really assist in improving the quality of your product. In fact, I'll come back later to this on why these kind of insanity tests make your product more buggy rather than less buggy. Our job as developers is to embrace this art form of being able to test your product with genuine production examples and yet still find the bugs that make our application crash. Circling this back to the database, you might be thinking, well, hold on a second. When it comes to bugs I find in the database or any vendor product that I'm using, surely this is the vendor's problem. I mean, isn't Oracle meant to be finding the bugs in the Oracle products? Yes, of course, this is true. And all I can do to assure you on this is Oracle literally has hundreds of thousands of test cases that we cycle through as we're building each version of the Oracle database. When you find bugs and report them, and we have test cases for that, we add those to the list. But my point is, when it comes to testing an application to destruction, finding where your particular application will fail, the largest risk area generally is not in database features in their core. The largest risk area is when we start having combinations of those features in customer-specific situations. They are extremely hard to test for within the Oracle database development team. Let me give you some real examples of that I've encountered over the years of using the Oracle database. In early versions of Oracle, the dual table that we all know and love was a genuine, real table. It was a one-row table created in the system tablespace. Back in Oracle 8 and before, to read a single block, single row table requires 5 logical IOs. That sounds counterintuitive, but in those days, you read the segment header block for a one-row table 4 times in the process of then moving on to read the block for the table itself. In 9i, that was improved to 3 logical IOs to read a single block table, but also around that time frame, there was a fair bit of disparity between the features available in the SQL engine versus these features available in the Peel SQL engine. The nice binary compatibility between the two that you see nowadays was not there just yet. This meant to access particular SQL functions that we take for granted in Peel SQL required you to do select from dual in order to invoke the SQL engine from within Peel SQL. 5 logical IOs from the dual table could add up quite quickly when you have a lot of Peel SQL functionality performing select from dual. There was a well-known workaround to this issue of 5 reads from a single block table by creating your own dual table as an indexed organized table, or IOT. A full table scan on an IOT that comprised only the root block required only 1 read. We could bypass the various segment header details. Going from 5 reads down to 1 read might not sound like a big deal, but that's in reality a 500% improvement, and when you're issuing select from dual hundreds of thousands of times, that was a noticeable benefit on the hardware of the day. For those of you who aren't dinosaurs like myself, you may have never ever noticed this because in 10G we did away with all of that and introduced the concept called fast dual, where all queries to dual are just a memory operation that bypass the database altogether. How does the dual table relate to testing to destruction? It turned out, back in 8i and 9i, that if you had a materialized view, which was a fast refresh and was on a updatable join view, then if you had a local dual table, which was an IOT, that broke the materialized view. It could no longer be refreshed. This, of course, was pre-Twitter, pre-Instagram, pre-TikTok days. But if social media had been present, should I really go screaming publicly about this particular bug on social media? Did I really expect Oracle to find this bug during their testing? Don't get me wrong, it is definitely a bug, but the circumstances are literally quite bizarre. You have to have a materialized view. It has to be fast refresh. It has to be on an updatable join, and you must have created your own local dual table as an IOT in your own schema. If Oracle had managed to find that in their testing, I would have been absolutely blown away. Here's another example more from an infrastructure point of view. I worked with a customer many years ago. I was configuring the 11.1 grid clusterware on IBM Power machines using AIX 5.3, I think. And it turned out that on this particular platform, if you were planning on using direct NFS, then there was some strange clashing with the multicast address and TCP/IP traffic where IOs would then have intermittent 60-second waits. I gave a talk on this particular issue many years ago at user group conferences before I joined Oracle because some of this was discovered right in the middle of a production upgrade. The system I was building and upgrading at the time was standing to lose $1 million per minute if we couldn't get this problem solved. I remember at 4 a.m. asking the system operators for the CEO's phone number to let them know that we were going to struggle to be up for business the next day. Luckily, we did manage to work around it. Once again, yes, that's a bug, but a very specific set of circumstances. Very hard for any developer or tester inside the Oracle development team to find. You had to be on the clusterware version of 11.1, on a particular version of AIX, and you had to be using direct NFS and have a particular multicast address configuration. And just to prove it's not all historical stories here, here's an example that happened literally yesterday. We had a Ask Tom question came in from a customer. They've discovered that when you have a table with a function-based index and you have a trigger on that table at any level, row level or statement level, and then you run alter table move online, the trigger gets marked as invalid at the end of the operation. An invalid trigger is not really a big drama. It's auto-compiled on the next usage and something you would almost never ever notice. But interestingly, when I was investigating this, a function-based index typically adds a hidden column with an expression on it. So I tried replicating the issue with a virtual column using the same function that's in the function-based index. No problems. I tried using a hidden column or an invisible column, which is a feature available from 12 onwards. That's fine. Even if I put an index on that hidden virtual column, which is almost 100% synonymous with a function-based index, that's fine. If I do the move in offline mode, that's fine. It's only this particular set of circumstances, function-based index, with a trigger, online table move, the trigger gets marked as invalid. Is it a bug? Yes, indeed. But once again, it's an incredibly odd set of circumstances, compounded by the fact that nothing actually breaks at the end of the exercise. The application doesn't crash. So I'm unsurprised that this is a particular bug that might slip through test cycles. Please don't get me wrong here. I'm not suggesting you give a vendor, Oracle or otherwise, a free leave pass when it comes to testing their products. If you notice a regression or a bug in what I would consider just stock standard vanilla functionality, something that you would expect to definitely be picked up during a standard test cycle, please call us out on it. Anytime you do this, it helps us improve our process, which ultimately will help you in terms of database quality. Similarly though, for the apps and code that you write, remember that in that respect, you are the vendor in this case for your customers. It's important to set yourself the same high standards. Don't let bugs on vanilla functionality slip through, and just as importantly, make sure you test to destruction to examine all the potential strange circumstances that are unique to your application code and make sure that they don't fall into production bugs as well. So if your vendor, Oracle or otherwise, might not find all the bugs that you would like them to find, what can you do about it? From a developer's perspective, I break this into two areas, namely the building of features and the testing of features. When it comes to building features, I like to think of this as the topic of innovation versus pioneer. To innovate is to generally exploit a functionality in order to gain some sort of competitive advantage, either with other vendors or really to give a better experience to your customer. It's some benefit you're exploiting out of the functionality in your code base. A pioneer is similar, but a pioneer I think of someone who blazes a trail into the unknown. There's perhaps a subtle and sometimes tough to distinguish difference between an innovator and a pioneer. The easiest way I like to think of it is when you think back to the true pioneers of the world, those who explored new lands, a lot of them perished. And that's what you don't want to happen to you or your code. So as you're building your application and writing code and using some of the features, whether it's in the Oracle database or any other platform, the thing I urge you to do when you're building your code is to think, am I the first ever person to consider this use case? Now, how do we know? Well, that's the joy of social media. You can jump onto Twitter, you can jump onto various forums, you can use user group meetups, etc. Ask the question out on social media platforms, I'm building this with this particular feature, I'm planning on using it this way, has anyone else done this? Here's why that will always help, no matter what the responses are. If you do get responses, you're going to get people's experiences, you're going to get their hiccups and their pitfalls or the successes. You might get just straight out responses of, don't do this, we tried it, it doesn't work. That saves you a lot of effort. But consider the alternative, where you get no responses. If you get absolutely no responses, then perhaps you're crossing that line from being an innovator to a pioneer. If you are the absolute first person to ever consider using a feature in a particular way, then your risk profile might have just jumped a whole lot. An example I saw of this recently on Stack Overflow was a developer asking for a solution to the age-old problem of how do I have more than 1,000 elements in an in-list in Oracle SQL. I applaud the developer for asking the question to gain opinions from the rest of the community. However, in this particular case, most of the responses were advising the developer against this approach. There were responses like, it sounds like you need a table, or look at using a subquery, or a pipeline function to get those elements back, etc. Look at using a join. Unfortunately, this developer kept insisting that none of those were an option and he just needed to get around this issue, and eventually they opted for just going with an OR clause and kept adding more and more bunches of 1,000 items in an in list. I can't comment for certain, but I'd be willing to bet that we don't have a test case inside Oracle for the situation where you have 50,000 elements in an in list and the way you're implementing that is with 50 individual 1,000 element in clauses concatenated with OR statements. You're very quickly heading into pioneer territory there. Once you have explored a particular feature and you have committed yourself to using it or building a feature on it, I think you really need to own it then, which means that testing to destruction phase becomes critical. The three most common traps I see developers falling into when it comes to testing their code to destruction are: 1, the unit tests run fine and therefore they assume the product is fine. I generally don't see unit tests as a validation of the product working. I like to think of unit tests more as a validation of the product not regressing when you make changes. That's where unit tests can really come into their own. I never like to think that a unit test validates my approach 100%. The second trap is more of a cultural one. Namely, I think developers run that risk of getting overly defensive about bugs, or defensive toward testers when they find bugs in their code. The successful developer, in my opinion, is the opposite. When someone finds a bug in your code, you're actually happy. You're ecstatic almost. Think of it this way. That person has probably just saved you from a 2 a.m. phone call and emergency production release. Conversely, it's important to be frank in your discussion with people testing your product in terms of the kind of bugs that they might find. Recall earlier in this episode, I mentioned the issue of when testers who are motivated to find bugs under any conditions end up doing things like, oh yes, if I try log a quantity of 1 trillion when I'm ordering products, then the application crashes. Those kind of unrealistic test cases ultimately runs the risk of your application having more bugs rather than less bugs. Because if you have hundreds of unrealistic test cases, each of which you've put a fix in for, you now have this wonderful situation where it looks like your product has a 99% success rate when going through tests. However, only a tiny fraction of them are targeted toward the genuine production use cases that customers will be unleashing onto your product. It's very easy to have an inflated opinion of the quality of your product if it seems to be passing hundreds of tests, when beneath the covers, none of those tests are realistic production circumstances. The third trap for developers is over-reliance on testers. This is what I call the lob over the fence concept, where you build your code and you simply lob it into the test department and say, good luck with that, see if you can find any problems. The vast majority of the time, testers will not know the internals of the application code you have written, but you do as a developer. You know where the likely potential spots of failure might be. You may have coded an array, or if your code uses lots of arrays, you know that an array out of bounds is an exception you'd really want to be focusing some test areas on. Similarly, from a SQL perspective, if you're building up an in list, you want to make sure that you don't cross that boundary of 1,000 elements. As a developer, you're best equipped to know some of the potential weaknesses of your own code. You just have to embrace that. Two other areas where developers are particularly well equipped to find shortcomings in their product is concurrency testing. How does multiple users using your application at the same time hold up in terms of locking, validity of results? The Oracle read consistency model is a common catch-out point here for developers who don't understand how it works. And of course, scalability tests. What does your app do? How does it perform when it hits those potential production volumes and above? Although, once again, I will stress, you don't want to be wasting effort on meaningless tests. Logging a bug saying, oh, my application can't handle 1 million transactions per second is a pretty silly test if you only have an active customer base in the thousands. It is, of course, a valid test if your active customer base is in the tens of millions. So, what are some examples of how I might choose to test an application to destruction, focusing for this example on the Oracle database? Let's say I'm building a typical sales application where I'm going to have a transaction or sales table which is going to take all the customer orders. One would imagine that during the build cycle, my development and test databases, that table is going to be tiny because there isn't much volume yet. One of the first things I would do when it comes to completing my testing of this application would be to load it up with the expected production volumes at, say, 5-year time span. Let's face it, many applications nowadays are rewritten within that time frame anyway, so if it can handle 5 years worth of load, it's probably going to be doing just fine. The big question, of course, is how do you load a table with data that you don't have? It's remarkably easy with the Oracle database to generate test data with simple SQL statements. Probably the most common one that most of us are familiar with is the connect by clause on dual trick to hierarchically loop through the dual table as many times as we like. That is more powerful when you consider the functions available within the Oracle database. I can use the mod function or the trunk function around numerics to come up with clusters of data. If I need to spread the data out over a restricted finite range, I can use mod or trunk to reduce the row set down. So I might want just 1,000 distinct customers in my sales table of 100 million rows. Similarly, I can use the DBMS random package to generate random numbers or even random strings. For more domain-specific test data, there are plenty of free data sets out there on the internet that you can use, download, and load into your database. Or one of the really cool resources I'd recommend is Morten Egan's tool called Random Ninja. I'll put a link in the podcast description notes, and he has a whole suite of PL SQL-based tools to generate the common domains in terms of phone numbers, names, credit card numbers, etc. And the next level up, of course, you can go to fully commercial tools if your budget allows to have all sorts of test data created for you. But I really do believe that having an argument that, oh, I couldn't make my table large in dev because I couldn't generate test data is perhaps not a valid one to make. Another benefit of loading up your environments with test data in this way is when it comes to potentially loading up existing data into your new application in production, you'll have an idea of how to best go about loading large volumes of existing data should that requirement exist in your application. Once I've got some representative production levels of data in my non-production environment, I can run things like reporting tests. How do the various transaction reports that will be required in my application run against this new larger data volumes? I'd also run my transaction tests. You may be thinking that the existing size of a database table makes little or no difference to the cost of adding new rows. But if this transaction test is following your reporting testing, well, you may have added new indexes to help with the reporting performance. You may have partitioned the table to help with reporting performance. The indexes that are used for transactions may now have an additional level, or the density of those index keys may have changed. The amount of leaf blocks you need to access per index key for non-unit indexes may have gone up as well. All of these things may impact your transaction throughput. As you're running these transaction tests now, that may lead to some measurements of index contention. Maybe if you're using sequencers, you might need to change the case size to handle the expected transaction loads. Similarly, if your transactions come back and update existing rows, maybe the volume has some implications in terms of the percent free setting. If you're going to have row growth, maybe the percent free needs to be bumped up to avoid row migration. But in high volume environments, even though you're not changing the rows, you might need a high percent free to handle the number of ITL slots that might be needed to handle concurrent transactions on a block by block basis. having those full-size environments, even temporarily, is vital to making sure you can do testing to destruction. And of course, once you've completed your reporting tests and your transaction tests, you of course now will run your reporting tests during your transaction load tests, because in a real-world situation nowadays, we generally don't separate the two. Customers are busily adding new transactions while other customers are busily doing reports. Those full-size environments also helps you in terms of your DBAs. They will be wanting to test things like archival. Do you have purge jobs, for example? They might run a lot slower now that you've got some full-size data. Maybe your backups are going to get very long. Your backup duration typically is proportional to the size of the database, so that's another thing you might need to take into account. You may even want to do some experimenting with copying your test environment back to your development environment to get an idea of how long it's going to take to clone a full-sized environment. All of these things give you that extra level of confidence that your application is going to run as designed at the levels you expect in your production environment. If we look at testing from a concurrency perspective, as a developer, if you ever wanted to mount a justification to your manager that you need more than one monitor or more than one laptop on your desk, this is the perfect time. Part and parcel of your work as a developer is to fire up the application, if possible, multiple times and try do similar activities in each. Whether this is a manual fashion or whether it's in automated fashion, you want to make sure that the application responds well even when it's being used under concurrent conditions. We often have questions on Ask Tom about how to do concurrency when an application runs so fast. If you're exploring, for example, row-level locking, how do I get an application to take locks for slightly longer than they normally would so I can actually see how my application would respond under these conditions? One way of doing this is to add some triggers to the table which have a simple call to dbms session.sleep, or in older releases, dbms lock.sleep. In that way, as transactions are undertaken, the triggers will fire and slow down the duration of these transactions. In that way, you can deliberately explore what happens when locks are held for a longer duration than expected. These are the kind of tricks and tools you can use to explore the outlying conditions of your application, whether it's under load conditions or under extreme locking conditions. Make sure your application works in these scenarios, and there's a very good chance it's going to work in all scenarios. So like most of my podcast episodes, I've jumped around a bit here as things just spring into my mind. I am pretty much just doing a brain drain into the microphone. So in terms of summarizing this, I think the key thing here is, as developers and as DBAs, we need to have a very strong focus on not just the building of applications and even the designing of applications, both of which are important things, but also our ability to help our test departments make sure our applications are going to handle the rigors of production usage. For our applications to be truly successful, we need to not treat them as our children or as our babies. We need to give them a little nudge out of the nest, so to speak, and let them spread their wings. And in that way, those parts of the application that go smashing into the ground are where we're going to focus our efforts on improving them. Testing an application isn't just about making sure it works, it's about how we're going to find where it doesn't. I hope this gives you a good idea of how I think testing applications or features on the Oracle database is best tackled. It's served me fairly well over the years. Thanks very much for listening. As always, hit me up on Twitter if you have any questions or requests for podcast episodes. I'll be back with another episode to help you be more successful with the Oracle database. Bye for now, everyone. Thanks for listening to this podcast. The music credit goes to Zanman from Pixabay Music.